Let's imagine a journey into matter. From here to the nanoscale. How long would this journey take? How familiar would the nanoworld be? What would be unexpected? Most everyday objects around us are three-dimensional. But in July 2014, Nicolas, Adrien, and myself made a very unusual object, a nanotube. This is a tiny one-dimensional object made up only of carbon atoms. To make it, imagine a sheet made of carbon that is only one atom thick, and then roll it into a tube, and that is your nanotube. These tubes have amazing properties. They are stronger than diamond, they can emit light and even conduct electricity. Above all, we were fascinated to discover how their small size affects their properties. We usually grow out nanotubes out of nanoseeds on a surface. Unfortunately, during that summer it was very hard for us to do that. The oven we used to grow nanotubes was not working properly. Instead, we tried another idea. We heated many of our nanoseeds lumped together in our oven, which is what we see here. We see cracks, valleys, canyons, plateaus that look strangely familiar. But why is it similar to dry land? Was there water there? When the crust of nanoseeds dries up, it forms cracks, like dried mud. This is the beauty of physics. Some of its laws are the same at nano and human scale. Now we are slowly approaching one peculiar crack, where the crust of nanoseeds bends upwards to form a tent-like cave. On both sides, we can see ropes, creepers. Sometimes they merge. There must be some interactions between them to form bundles or single strands. These are the nanotubes we were looking for. They have a diameter of 1 nanometer. From the work of our colleagues around the world in the last 20 years, we know they behave like guitar strings. Increasing the tension or reducing the length raises their pitch. As they are purely one-dimensional objects, they are extremely light, being made up of only few carbon atoms that constitute them. This allows us to use them as the most precise measuring scales in the world. Like a guitar string, we can measure their vibrations. But the nanotube is so extremely light that its vibrations change if we deposit just one extra atom on it. To explore the nanoworld, full of new phenomena, we need tools to observe it. This type of nano-measuring scales is one of them. Another tool is the microscope we used to create this video. It is a scanning electron beam microscope. In this microscope, a very narrow beam of electron is scanned very rapidly over the sample. And every time that beam hits a carbon nanotube, a single click is measured. By mapping out these clicks, we can form an image with extremely high resolution. At this stage, it is impossible to see smaller details, or the atom constituting the nanotubes, because we have reached the limit of our instrument.